Okay, this is your lesson on trig functions, section 2. In this section, you will use ratios of the sides of a right triangle to define sine, cosine, and tangent. Use a calculator to find trig functions in radians and degrees. Evaluate the six trig functions using the unit circle, and find the six trig functions given a point on a coordinate plane. Okay, we have SOHCAHTOA. Sounds like an Indian princess, but that's really the relationship of the sides of a right triangle to find the basic trig functions. You probably learned this before I think probably geometry. Okay, sine is the ratio of opposite over hypotenuse, which is so, okay, opposite side to the angle that we're interested in. This one is marked at angle B. It could be angles A or B, but not C. C is the right angle, and we don't do that one. So using angle B, the opposite side would be the farthest side, and the hypotenuse is always the side that's away from the right angle. So you have this angle here would be opposite. The one next to would be adjacent. Adjacent means next to. So next to my angle would be the adjacent side. And that's be cosine. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And realize that these will be switched if we're interested in angle A. Angle A, then the side CB would be the opposite side, and side AC would be the adjacent side, because that would be next to A and opposite A. But right now we're talking about B, so this is opposite B and adjacent to B. So SOHCAHTOA. All right. So this is by definition. Here we go: sine, cosine, and tangent. SOHCAHTOA. And then we have the reciprocal trig functions. Cosecant, abbreviated as CSC, is the reciprocal of sine. So it's going to be, instead of opposite over hypotenuse, it'll be hypotenuse over opposite. And you can put that in your calculator doing this way. There is no button on your calculator for cosecant, so you put 1 over the sine of your angle. Or you can put in parentheses and use the reciprocal function. Your reciprocal function looks like this on your calculator, and you can put that on there like that, and you'll also get cosecant. Using the same method, we can get the secant of an angle by using the reciprocal of cosine. That would be hypotenuse over adjacent. Or you can put cosine reciprocal. That will give you secant. And then cotangent is the one that goes with tangent, and that would be adjacent over opposite. And that's 1 over tangent. Now, to help you remember, it's not S doesn't go with the S. S goes with the C, and C goes with the S. That's how I remembered when I was first trying to learn this. Sine goes with the cosecant, and the cosine goes with the secant. Okay, the letters not consistent. All right. Okay. Use a calculator to evaluate the expressions to 4 decimal places. Find the sine of pi over 6. Now, the very, very important thing here, your calculator has to be in the same mode as your angle. In this angle, since I don't have a degree symbol, this means that this is a radian. So your calculator must be in radians for you to get the right answer. Now, I don't know how all of the calculators out there work. On the TI, it's under mode. On the Casio, it's under shift setup. slide down to where it says angle and change that from degrees to radians. Okay, and then now you can put in sine of pi over 6. Now, if you have a different calculator, then you'll have to change it, find some way to change it. And on most calculators, this is so important that it's actually on the display all the time. It either says DEG or RDA. Okay, so make sure you have the radian setting on there. If you do that, you should get 1/2 or 0.5. Okay, and if you know from the unit circle, you know that would have been 1/2 anyway. Okay, tangent of pi over 2, so that's in radians, so we're still good. Tangent of pi over 2 and we should get undefined, because that does not work. You can't take the tangent of pi over 2 because you're dividing by 0. Okay, what about this one? Cosecant. So I'm going to, cosecant is the reciprocal of sine, so I'm going to put sine in parentheses sine. And you have to learn to use your calculator. You have something else. If you have a scientific calculator, make sure you know how to do that. And then this is going to be 1.3, and then close my parentheses, and then use the reciprocal. On the TI, I believe it's in the middle to the left. On the Casio is shift close parentheses, and you should get 1.0378. All right, and then cosine of negative 97 degrees. Now, remember when I said before, your calculator is probably in the radians mode at the moment, so you have to change it back to degrees, and then you should get negative 0.1219. There is a shortcut. You can ask me about that in class for your graphing calculators. Okay. Secant. Now we're in radians again. So this is a reciprocal of, what's that reciprocal of? Cosine. So you're going to put cosine in parentheses and take 1.8. This one is in radians. Make sure your calculator is in radians. And do the reciprocal. And you should get negative 4.4014. This one's in degrees, so make sure your calculator's in degrees. Cosine of negative 160 degrees, negative 0.9397. This is in radians, and that is negative 0.7404. Tangent of 1 degree is 0.0175. Okay, now that you know how to put them in your calculator, let's try some ones that we won't need the calculator. Okay, we want to find the 6 trig functions for this. Now we are given 2 of the sides, and we can get sine of this angle right here. The opposite is 5, and then hypotenuse is 13. So it's 5/13. Now if you want to find the cosine, you need the adjacent side. But we aren't given the adjacent side. How do we find the adjacent side on a right triangle? Okay, the Pythagorean theorem. A squared plus b squared is equal to c squared. Solving that, we should get 25 minus 25 from 169. We get 144. Take the square root. Normally, when we take the square root, we get a plus or minus, but we're only going to take the positive one because a negative side doesn't make any sense. So it'll be a positive 12. That's side A, the missing side. Now that we know that the adjacent side is 12, we can say 12 over the hypotenuse, which is 13. Tangent is opposite over adjacent, so that would be 5/12. Now it says give all 6, so now you just take the reciprocal of these. Cosecant is the reciprocal of sine, so it would be 13 over 5. Secant would be a reciprocal of cosine, it's 13 over 12. And cotangent is 12 over 5. Okay, you try this one, work it all the way through. All right. Okay, so you're going to find this with the Pythagorean theorem. And it's 225 minus 81, which is 144. And we get 12 again. Okay, so we have sine is opposite over hypotenuse, 9 over 15, adjacent over hypotenuse, which is 12 over 15, and tangent would be 9 over 12. Now notice that the tangent can be opposite over hypotenuse or opposite over hypotenuse, like sine over cosine. It'll be sine 9 over 12 because the 15s cancel. So that's another way of getting tangent if you have sine and cosine already. Okay. Now the reciprocal of sine is cosecant, 15 over 9. Reciprocal of cosine is secant, 15 over 12. And cotangent, 12 over 9. Now really all of these should be reduced by 3. Okay, I didn't reduce them here because I didn't want to confuse you and have 3 over 5 and you're going to go, oh, where did the 3 over 5 come from? Well, it's 9 over 15, which should have been reduced to 3 over 5, 5 over 3, 4 over 5, 5 over 4, and 3 over 3/4 and 4/3. Okay. All right. Next, going from quadrant 1, 2, 3, 4. It's all students take calculus as the acronym that we use to find out what the positive, whether it's positive or negative. Everything is positive in quadrant 1. Okay. In quadrant 2, sine and tangent are negative. I mean, cosine and tangent are negative, and sine is positive. So that's why we say student for S, sine, S for sine, and S for student. Take would be T for take and T for tangent. That's the one that's positive. These two are negative. And for cosine or C, we have calculus. So all students take calculus. All of them are positive. Only sine is positive, S for student. Only tangent is positive, T. And only cosine is positive for calculus. That's to help you remember. Okay. And of course, all the reciprocal trig functions will have the same positive or negative on it. So all of them will be positive here, and sine will go with cosecant. So cosecant and sine are both positive here, and everything else is negative. Tangent and cotangent, and also cosine and secant are positive in quadrant 4. All right. find the exact values of the 6 trig functions given a point here, 5, 12, and we're going to connect it to the origin. So if we do that, we know that it's going to go over by 5. This point goes over by 5 and goes up 12. And if we draw a line there, we get that angle. Okay, so if we want to find all 6 trig functions for this angle here that's made by the line that connects the origin with this given point of 5, 12, we can think of this as a triangle. And the width of my triangle, the base, is 5, and the height is 12. So now we have theta in this corner, and we're going to have the hypotenuse, and we can find that with the Pythagorean theorem, which is 13. All right, so now we're going to find the 6 trig functions. Well, we know cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, tangent is opposite over adjacent, and then secant is the reciprocal cosine, cosecant is reciprocal sine, and cotangent is the reciprocal tangent. All right, so let's try one more. Find the 6 trig functions for this point made by the line that's connecting the origin to that point. So going over would be 4 and going up would be 3, drawing that line in. That's the angle that we're talking about. And if we think that as a triangle, you know that the base of the triangle is -4, and going up is 3. Now notice that there's a sign on that -4. Even though we can't have a negative side on a triangle or any geometric shape, but we have to keep that sign there, the negative, so that we can keep track of what's going to happen to our trig functions. Okay, then we get the hypotenuse using the Pythagorean theorem. That's 5. So now we're done. We'll just have to write the ratios. So if a -4 over 5, sine is 3 over 5, tangent is 3 over -4, and secant is -5 over, or +5 over -4, and cosecant is 5 over 3, and cotangent is -4 over 3. Now notice when we were talking about earlier about all students take calculus, notice that the last problem everything was positive, but in this quadrant, quadrant 2, all students, so only sine is positive and it's reciprocal. These two are the only ones that are positive. All the other ones have to be negative. Okay, that's how you check if you are missing a negative sign somewhere. All right, one more. See if you can finish this one. So we have -8, -15, draw my line, draw my triangle. Okay, notice when we're drawing these, they kind of look like a bow tie. Let me go back here. Notice that when we draw the triangles, it's always in this shape. It's always like a bow tie. So whenever you draw it out, you're going to connect it straight down to the x-axis to make like a bow tie. Okay, no matter where the point is, you draw it so it comes back down like this to the x-axis. All right, let's go back to our problem. Okay, we have this point here, and that would be the lower, I guess, lower left corner of our bow tie. And then we just use Pythagorean theorem, and we get 17. And that's it. We're just going to take our ratios. And here we go. Once we're done with our ratios, notice that in quadrant 3, everything's negative except for tangent and cotangent, right? All students take calculus, so those are the ones that are positive. Okay, just this one's positive. The other ones are negative. All right, that's it. Make sure you do the Google form.